I hope you can hear me. So I'm just going to redo the intervention exercise on this video. So let's start. Okay, here you can see I drew a table. I gave you a few numbers. I need you here to square the number. How does it look when we square a number? We multiply it by itself. And when it's given in exponential form, you just write the number with that small 2 at the top there, meaning it's in exponential form because that small 2 is the exponent. Okay, and then here in this column, I want your answer. So let's quickly do it. I've given you an example here of the number 5 and how I would want it done. So now let's do -7. As I explained to you guys in the class, we would want a bracket for that one. So it's going to become bracket -7 close bracket times bracket -7 close bracket. Then if you were to put that in exponential form, I also need your brackets. I also need to see your brackets there, and then you just write your exponent for me there. Then we write the answer. Think for yourself, do you think the answer will be in negative or positive? I think it would be positive because we all know that a negative times a negative gives me a positive. So it's going to be positive 49. I'm just going to make my pen a bit thinner quickly. As you see, let's just draw it that way. There we go. Okay, let's close this down. Now, for the next one, we don't even need to write brackets. If you wrote brackets, it wouldn't be wrong either. Okay, so yeah, we can just write 8 times 8, which gives us in exponential form, that would be 8 squared. And then if you go and square the number, you would get 64 because 8 times 8 is 64. In terms of this one, you would get definitely 12 times 12. And if you had to write that in exponential form, it would be obvious that it is 12 squared. And if you go and multiply 12 times 12, you would get the number 144. Then in this case, we have another negative. So we have to go and put it in our bracket. So -95 times -95, both in brackets. And to write that in exponential form, we would again need -95 squared. And if you go and say, okay, 95 times 95, and you would get 9,025, but it has to be positive because negative times negative gives me a positive. So that would be 9025. Okay, I'm going to zoom in. I'm scared that not everyone can see. So here you go. I'm just going to zoom in for that one. Okay, now let's do this one. Here you can see I've given you the value of x and some numbers to the power of x. I want you to put the value of x in the space where x should be. So for example, in this row, we put 1 in the value of x each time. So now let's do that here. Now this one would be 2 to the power of, what is x, the value of x here? 2, which then gives us the value of 4. And in this one, it would become 3 to the power of 2, which is 9, because 3 times 3 is 9. And here it would be 6 to the power of 2, giving me 36, because 6 times 6 is 36. Here is the number p to the power of 2, which we all know cannot be written any further than that. P squared is just p squared. Now here, we need to make the value of x 3, as you can see. So let's do that. That's then going to become 2 to the power of 3, which is 8. Here it would be 3 to the power of 3, which is 27. Just to explain, 2 to the power of 3 means 2 times 2 times 2. And we know 2 times 2 is 4, but we need another 2 in there, so 4 times 2 is 8. Same thing happens here with the 3 cubed. Now, 6 cubed would be 6 times 6, which we already know is 36, and multiply that with another 6, which will give us 216. And for p, we can just write that would become p cubed. Now here we can write, okay, this is now going to become 2 to the power of 4 because we're now using 4 as the value of x. So now it becomes 2 times 2 times 2, which we know is 8, and times it by another 2, which becomes 16. And here we have 3 to the power of 4, which would become 81, because we know 3 to the power of 3 is already 27, and now we need to multiply it by another 3 to get 81. For the number 6 to the power of 4, you can go work it out. What is 216 times another 3? Times another 6, I mean. That would then become 1,296. And in the case of the number p, we would just have p to the 4th power. Okay, now that the tables are done, we can start moving on to question number 3, which is quite easy. We actually have done it in class. So when I have the same base number multiplied by each other, we can add our exponents. So this will then become 5 to the power of 2 plus 3, turning into 5 to the power of 5. Same thing happens here. This will then become 3 to the power of 2 plus 11, which gives us 3 to the power of 13. This one is easy. It's just going to become 74 to the power of 2 plus 2, which is 4. Okay, just going to move up here. This one now becomes r to the power of 3 plus 4 plus 7. So we know to make this addition sum easier, we know that 7 plus 3 is 10, plus another 4 will give us 14. So for the last one, as I said, if your base numbers are not the same, this is S, and this is S, these three, but this one is 6. There's no other 6, so the 6 will have to stay 6 squared. Multiplied by, now we can take our S's and add them together. Again, we can say, okay, 3 plus 7 is 10, plus 8 is 18. So it will become S to the power of 18. Okay, and now to move on to the next one. Question number 4. When we divide, it's exactly the opposite of what we do when we multiply. So it's going to become, when we have the same base number, we need to take our 12 and minus 10 from it, subtract 10 from it. So it's going to become x to the power of 12 minus 10, which then gives me x to the power of 2, or x squared. Same thing for y. This is now going to become y to the power of 17 minus 14, which is y to the power of 3. Same for t. It's going to become t to the power of 20 minus 14, which is 6. T to the power of 6. And then in the case of n, same thing. It's going to become n to the power of, it's going to become n to the power of 11 minus 8, which is 3. N to the power of 3. So let's move on to question number 5. We have done it in class, but I'm going to do it again. This will now become okay, first off, we need to get rid of these ugly brackets on the outside to make everything simpler for ourselves. How we can do that is we can take this 2, multiply it into the 2 right next to it, and then it's going to become this bracket. Don't forget these brackets. We only got rid of the outside ones. So inside it's negative x, and then there's still a square that we haven't touched yet. And then what is left here? It will become 4. Because this 2 times this 2 gave us a 4. Now we can get rid of these outside brackets to make it even simpler. This will then become negative x to the power of 4 times 2, which is 8. And we can leave these brackets because we have a negative there. We can leave it in its brackets because there is our last exponent. Now, for this one, we can say, okay, first, before we even start dividing, because we all know what we must do when there's a big division sign there, we must minus. But we cannot do that if we have these ugly brackets here. So let's get rid of them. To get rid of these brackets, we need to say, okay, first let's multiply this 5 by the 2, which then becomes x to the power of 10 divided by x to the power of 2, which then becomes easy because we know that 10 minus 2 is 8, so this will then become x to the power of 8. Okay, let's move down a bit. Now, for number C, it's very easy. You just follow that one law. This 3, remember, if there's a and there's no exponent, it means there's an invisible one there and an invisible one there as its power, because there's only one a and only one b inside the brackets. But I'm telling you to put them in brackets and then cube them. So give them an exponent of 3. So now this 3 needs to get multiplied by this 1 and by this 1. And we all know that 3 times 1 is, sorry, my thing is a bit slow. 3 times 1 is 3. Okay, so this will then become a to the power of 3 times b to the power of 3. Okay, next one. We can say, first off, let me move up a bit to here. We need to get rid of these ugly brackets. Let's quickly do that. So this is now going to become, okay, first, I want to tell you that there is most invisible power of 1 because 4 and z are not the same base number. So this 2 will need to go and sit over the 4 here and over the z as an exponent. So it's going to become 4 to the power of 2 times z to the power of 4 times 2 is 8. Now we can go and write the rest of our sum. So that is then divided by 4 to the power of 2, because the same thing is happening here. The 2 needs to go to both of those base numbers. So it's going to become 4 to the power of 2 times z. Oh my goodness, this thing. Skis times z to the power of 2 times 6. 2 times 3 is 6. So now this becomes a much easier thing to deal with. We know we have the same base number here and here as we do here and here. So now we can go and divide them. In i.e., we need to subtract our base numbers. Our exponents. So the 4 is going to become 4 to the power of 0 because it's going to become 4 to the power of 2 minus 2. Do you see that? Let me rather write it out for you. So it's going to become 4 to the power of 2 minus 2 times z to the power of 8 minus 6. Now we can go and write that as 4 to the power of 2 minus 2 will become 4 to the power of 0, right? And we know 4 to the power of 0 is also equal to 1, but I'll write that for you now. So this is now 4 to the power of 0 times z to the power of 8 minus 6 is 2. So in the end, we can go and write this whole thing as z to the power of 2, because this is 1, and anything times 1 is just that thing. So if I have 1 times z squared, the answer will just be z squared. Now the next one is very easy. It follows the same concept. We can just say that it's going to become 5 to the power of 2 minus 2, which then gives us 5 to the power of 0, which is just 1. There's your answer. Okay, now we can go and move on to this question. Question number, I think I was supposed to write 6 here. Question 6. Anyway, it says global oil production is currently 74 million barrels a day. How many barrels are produced in a week? So let's do number I. Hello? Number I. Okay. So we know that there are 7 days in a week. So we need to multiply 7 with 74 million. Okay. For now, I'm just going to write 7 times 74. Let's write it in a, a column form, so we can do the column method. So when we multiply 74 with 7, we can just add this million afterwards, and then we will have the correct answer. So we know how many zeros are in a million. It's 10 to the power of 6, so it means we need to just add 6 zeros onto our final answer. So if we take the number 74 and multiply it with 7, we're going to get the following. So let's first do 7 times 4, which is 28. So that's going to become 8, carry over 2. 7 times 7, we know is 49. 49 plus 2 is 51. Now we can go and say, okay, this will then become 518 million. 518 million. So let's go and add those 6 zeros. There's 1, 2, 3, 4, 5, 6. So this is the amount of barrels that are produced in 1 week. Okay. I'm soon going to move on to giving you these answers in scientific notation, because I'm then going to erase it and do the month, and then erase it and do the year. So let's go and write this in scientific notation. We know that if I've got a big number like this, I can just go and count my zeros. So we can write it as 518 times 10 times 10 to the power of 6. Now, we know that when we are writing in scientific notation, we want 1 digit. So if our comma is there, we got to move it 1, 2 spaces, which after it will become 5,18 times 10 to the power of, now how many spaces did we move back? 2, right? So we now need to go add 2 to that 6. So it's going to become 5,18 times 10 to the power of 8. Okay, let me quickly wipe that out. I hope you've written down the answers, because all of it I'm going to do like this. Okay. Hello. I don't want to wipe out anymore. Okay, there we go. So now number II. How many barrels are produced in 1 month? Now we can say, okay, this is then 74 times 30, because we're going to add our zeros later on. So 74 times 30. We know 0 times 4 is 0. 0 times 7 is 0. Now I'll put it in a placeholder 0. So it's going to become then 3 times 4 is 12. So 2 carry over 1. 3 times 7 is 21. Plus 1 is 22. So now we just need to go and add. 0 plus 0 is 0. 0 plus 2 is 2. 2, 2. So now we can just go and add our zeros onto that. Let's just scratch this. And then we know we got to add 1, 2, 3, 4, 5, 6 zeros. So there is the number of barrels produced in 1 month. Let's go and put that in scientific notation. So we know that we can write 2, 2, 2 times 10 to the power of, let's go count our zeros, 1, 2, 3, 4, 5, 6, 7 to the power of 7. Now, we know that we need only one digit, so let's move our comma 1, 2 spaces. So now it's going to become 2 comma 2, 2 times 10 to the power of, what is our new exponent going to be? It was 7, but we moved our comma 2 spaces back, which means this now needs to turn into 9, because 7 plus 2 is 9. So there is your answer for B as well, putting it into scientific notation. This is the answer for A2. Okay, so let's quickly wipe that out. And then we'll do the last one. We're almost done, guys. Not much longer to go. Where's my mouse? Hello. This thing. Thank you. Okay. Last one. We've got 365 days a year. So let's write the bigger number at the top. 365 times 74. Okay, now we know 5 times 4 is 20, so 0, carry over 2. 4 times 6 is, let's check, 4 times 6 is 24, plus 2 is 26, so 6, carry over 2. 4 times 3 is 12, plus 2 is 14. Now let's put a placeholder 0 because we're moving on to our second digit. 5 times 7 is 35. So 5 carry over 3. 6 times 7 is 42 plus 3 is 45. So 5 carry over 4. This now becomes a 4. 7 times 3 is 21 plus 4 is 25. Now we go and add. So we know 0 plus 0 is 0. 6 plus 5 is 11, so 1 carry over 1. Then this one becomes 5. 5 plus 5 is 10, carry over 1. Now this one becomes 2, so 2 plus 5 is 7, and then this just goes down as 2. So let's go add our zeros. We now have this number, so let's go add 1, 2, 3, 4, 5, 6 zeros. Okay, so that is the number of barrels produced in a year. So let's go and put it into scientific notation. We know that we have 2, 7, 0, 1, and then let's count our zeros. 1, 2, 3, 4, 5, 6, 7. So that's times 10 to the power of 7. Now let's go put our digits. We know we only want one digit, so move our comma 1, 2, 3 spaces. So now it will become 2, comma 7, 0, 1. Where's my 0? Thank you. Times 10 to the power of, how many spaces did we move back? 1, 2, 3. So 7 plus 3 is 10. So that has been the intervention of exponents. Let's go check everything we did, rewatch everything. Okay, I hope you guys understood everything. We'll talk about it on Monday.